Hi everybody, in this video series we're going to take a look at using the standard reduction potential table to predict redox reactions. Now this table is found in your data booklet and you should have it handy for this lesson. The standard reduction potential table, or SRP table, can be used to predict whether a chemical species will spontaneously give electrons to or take electrons from another species. And by spontaneously, we mean without needing to add any additional energy to make the reaction happen. It's going to just happen on its own. Oxidizing agents, which are species that take electrons, are found on the left side of the table. Reducing agents, which are species that give electrons, are on the right side of the table. A chemical species in the left column of the table will only take electrons spontaneously from species below them in the right column. And a chemical species in the right column will only give electrons spontaneously to species above them in the left column. In this example, we're going to use our SRP table to predict whether a spontaneous reaction will occur. So for an example A, we have iron 3 iron reacting with chloride ion. The first thing we want to do is find each of these ions in our SRP table. And so we can see that we can find the iron 3 ion on the left-hand side of the table, so it is an oxidizing agent. The chloride ion is found on the right-hand side of the table, so it is a reducing agent. However, if we look at the orientation of these two ions, the chloride ion is actually above the iron 3 ion. So that means that this will not be a spontaneous reaction. A spontaneous reaction will occur when the oxidizing agent on the left-hand side is above the reducing agent on the right-hand side. And this is not the case in this situation, so this will not be a spontaneous reaction. Go ahead and try the next two examples on your own and refer to your work text for the solutions. In this example, we're asked to determine whether chlorine and sodium bromide will spontaneously react to produce bromine and sodium chloride. If so, write the balanced net ionic equation for the reaction. So I'm actually going to start here by writing the complete reaction, the formula equation out. So I'm going to have chlorine reacting with sodium bromide. Remember that chlorine is diatomic, and that's going to yield bromine, which is also diatomic, and sodium chloride. I'm going to balance this by putting a coefficient of 2 in front of sodium bromide and sodium chloride. The complete ionic equation will show the ions for sodium bromide separated, dissociated into its ions, and also for sodium chloride. So I'm going to write them as sodium ions and bromide ions and sodium ions and chloride ions. And we can see here that sodium ions are a spectator. They appear as both a reactant and a product. So I'm going to not show those in the net ionic equation. So I can see I have chlorine reacting with bromide ion to form bromine and chloride ion. And so by analyzing my oxidation states, I can see that chlorine is actually getting reduced. So it is the oxidizing agent in this reaction. The bromine is getting oxidized, so it is the reducing agent in this reaction. And so I want to find these two species on my SRP table, and in this case I can see that my bromide ion is below the chlorine, so my reducing agent is below the oxidizing agent. And that means that this will be a spontaneous reaction.